All right, so you're building an application, maybe in Go, maybe in something else, and you hit this huge fork in the road pretty early on. How are you going to store your data? Well, today we're breaking down one of the biggest architectural choices a developer has to make, the classic showdown, SQL versus NoSQL. You can think of it like this. You're about to build a house, right? Are you going to start with a super rigid, pre-approved blueprint where everything is defined up front? Or do you want a more flexible design that you can kind of change and adapt as you go? That's really the question we're answering today, but for the foundation of your application's data. Okay, let's get into it. At its core, this isn't just about different technologies. We're talking about two completely different philosophies for how to organize information. And to make it all click, we're going to start with a really simple analogy. So on one side, you've got SQL, the relational database. I want you to picture a perfectly organized spreadsheet. You've got strict columns, you've decided exactly what kind of data goes in each one, and every single row has to play by those rules, no exceptions. Then you've got NoSQL. This is way more like a flexible folder. You can just throw different kinds of documents in there. Some are long, some are short, some might have images, and each one can have its own unique structure. The key words here are really structure versus flexibility. Now, you've definitely run into these SQL players before. I mean, they're the titans of the industry, right? You've got MySQL, which is the classic workhorse that basically powered a huge chunk of the early web. Then there's PostgreSQL, which a lot of developers love for being so robust and packed with advanced features. And of course, you can't forget Microsoft SQL Server, which is just a dominant force in the enterprise world. What's really cool about the NoSQL world, though, is how diverse it is. It's not just one thing. It's this whole category of super specialized tools. You've got document databases like MongoDB, you've got column family stores like Cassandra, you've got these lightning-fast key-value stores like Redis, and even graph databases like Neo4j. Each one is engineered to do a very different kind of job. All right, this table right here, this is basically our roadmap for the next few minutes. We're going to walk through these key differences one by one, from how they handle their data models and schemas, to how they scale, and what kind of consistency you can expect. Let's dive in. So this brings us to the core trade-offs. Every engineering decision is really about balancing competing needs, and this is no different. We're going to be talking about rigidity versus flexibility, scaling up versus scaling out, and these two totally different models for data consistency called ACID and BASE. So the very first question you have to ask yourself is this: how well do I actually know what my data is going to look like? And just as important, how likely is it to change down the road? This one question pretty much defines your choice of schema. With SQL's rigid schema, you get amazing data integrity right out of the gate. The database itself is your bodyguard. It's not going to let you put a string where a number is supposed to be. But the big drawback, it can be a real pain to change. Imagine you have a massive e-commerce site with millions of products and you want to add just one new attribute. That's a slow, risky operation. NoSQL, on the other hand, is built for change. But, and this is a huge but, the trade-off is that the responsibility for keeping data consistent now falls on your shoulders, as the developer, right there in your application code. Okay, next up, growth. Let's say your application is a massive hit. How is your database going to handle that fire hose of new users and data? Are you going to build a taller skyscraper, or are you going to build a wider city? Traditionally, SQL databases scale up. We call this vertical scaling. You basically just buy a bigger, beefier server with more CPU, more RAM. It's simple to think about, but you eventually hit a ceiling, both physically and financially. NoSQL databases, however, were designed from the ground up to scale out, or horizontally. So instead of one giant server, you just keep adding more affordable commodity servers to a cluster. This is exactly how giants like Google and Facebook handle their insane scale. Now, this process of splitting your data across a bunch of different machines has a name. It's called sharding. And for senior engineers, this is where the real magic and the real challenge comes in. Choosing the right sharding key is absolutely critical. You get it right and your performance is smooth and even. But if you get it wrong, you can create these nasty hotspots that can bring your entire system to its knees.
And here's a perfect example that makes it crystal clear. Let's say you're building a messaging app in Go. If you shard your data by group ID, all the messages for a single group chat end up on the same machine. Super efficient, super fast. But what if you chose user ID as your key instead? Well, sending one message to a group of 100 people could mean writing to 100 different servers all at once. It would be a total performance nightmare.
All right, our final major trade-off. When you write something to the database, how soon is that new data guaranteed to be seen by everyone else trying to read it? Is it immediate and absolute, or is a little bit of a delay okay? SQL databases, they live and die by the ACID principles. This stands for atomicity, consistency, isolation, and durability. And it's a very strict contract that guarantees every transaction is completely reliable. Think about a bank transfer. You absolutely need the money to be taken from one account and added to another as a single all-or-nothing operation. That's the promise of ACID. NoSQL databases often take a different approach, a model called BASE. That stands for Basically Available, Soft State, and Eventual Consistency. This model prioritizes availability above all else. It's okay if, for a brief moment, different users might see slightly different data. Think about a social media feed. It doesn't really matter if you see a new like on a post 1 second later than someone else. Keeping the service up and available is way more important. So, we've been using this term NoSQL like it's one single thing. But in reality, it's more like an umbrella term for a whole family of very different databases. So let's break that family down a bit to get a clearer picture of what your options really are. First up, you have document databases like MongoDB. These things think in terms of flexible JSON-like documents. This makes them absolutely perfect for things like product catalogs or user profiles, where every single item doesn't need to have the exact same fields. Next, we've got key value stores, like Redis. And the name says it all. You have a key, and you have a value. That's it. That radical simplicity makes them incredibly, incredibly fast. They're perfect for things like high-speed caching or managing user sessions. Then you have column family stores like Cassandra, which are fascinating. They basically flip the traditional model upside down. Instead of storing data in rows, they organize it by columns. This makes them unbelievably efficient for big data analytics, letting you query a single attribute across, say, billions of records with total ease. And finally, we have graph databases like Neo4j. Their specialty isn't just the data itself, but the rich, complex relationships between the data points. They are purpose-built for things like social networks or recommendation engines, where understanding how things are connected is literally everything. So, after all that, which one is actually right for you? Well, it kind of boils down to this. Choose SQL if your data is highly structured and you absolutely cannot compromise on data integrity. Think financial systems. And choose NoSQL if your biggest concerns are handling massive, massive scale and having the flexibility to deal with constantly evolving unstructured data. But here's the modern twist. You might not have to choose just one. In fact, many modern systems embrace this really powerful pattern called polyglot persistence, which means they use the strengths of different types of databases for different jobs. And that leads us to our final thought here. A modern application might use a SQL database for handling user accounts and transactions, but then use a document database for its product catalog, and maybe even a key value store for session caching. So the ultimate question isn't really SQL or NoSQL, but which tool is right for which job. After all, your application has a lot of different needs, so why should it have only one database?